we will again use this COVID data, and you will use it for your homework as well. So we click Analyze, we click Comparison Regression, Linear Regression. So what I want to show you, for instance, and again, it's very important, your dependent variable in your linear regression should be interval ratio. If you have a variable which has like few values, like 3 or 4 or 5 or even 10, it means that you cannot use it as your dependent variable in your linear regression. In linear regression, dependent variable has to be interval ratio, and it should have like lots of values. So for instance, here, I want to see what affects income. So income would be my dependent variable. And then I will add a bunch of independent variables. For instance, what I like here. If you are fired, if you are, what's your sex? Because in the United States and in most countries, men make more than women, so it's important independent variable. Let's see, education, also very important. Let's say marital status. Check statistics. Yep, looks fine. So I ran my linear regression with a bunch of, I think we discussed it before, but let's go with one more time. So this is your R square. It is 0.01. It means that 1% of change in income is explained by these 4 variables. So it's not a very good model. Then you look at coefficients. Again, it's all significant. It's all smaller than 0.05, right? And it's also, again, significant in terms of t. It's all larger than 2, right? And this is, for instance, remember I talked about standardized coefficients. So if we look at these variables, you can see that the largest standardized coefficient is for education. So in this regression model, education is like more important in explaining difference in income than, let's say, gender. This is how you interpret standardized coefficients. And these are unstandardized coefficients. And what they mean that, for instance, a change from, for instance, look at the code book. To interpret coefficients, you need to know your variables and you need to look at the code book. So let's see sex. Yeah, so 1 male to female. Oh, this is actually strange. So when you do your regression, and if like change from male to female means an increase of 80% in income. I guess it's some kind of weird sample where most men are losers, but okay, that's interesting. So this is how you interpret coefficients. And this is how you do a multicollinearity check. What it says is whether or not there is a correlation between your independent variables. If you have a strong correlation between your independent variables, it means that you need to remove some of the variables which have a strong correlation. Okay. oops. So again, we go to analyze, we go to regression. Is it? Yep, here it is. We go to linear regression. And what we do, this is a bit strange. So what we do, oops, we remove this, and we do a bunch of things with those parameters. So fired. So you see what I'm doing? I'm running my regression among my independent variables to see if there is a statistically significant correlation between them. If there is, it's a bad thing for regression. So we click on statistics. We don't need this, but we do need collinearity diagnostics. We click continue, and we click OK. And we look at this VIF, variance inflation factor statistics. Oops. And how to interpret it. If it's smaller than 3, it means that there is no strong correlation among your independent variables. But again, in SPSS, it's a weird program, so you have to do it multiple times for like every combination. So let's do it one more time. Okay. Where is it? Regression, linear. I remove fired, and let's see, for instance, sex, and move sex to independent, to dependent, and fired again, to independent. Check statistics, again, collinearity diagnostics, continue, okay, oops. Again, look at the VIF, it's smaller than 3. It means there is no strong correlation between your independent variables. So this is how you do multicollinearity check in SPSS. And it's important, every time you do a regression which has a bunch of independent variables, you need to do this multicollinearity check. It's like, I don't know, brushing your teeth in the morning. And this is how you do it in R. I posted this file in content section. So setting working directory, importing data, oops, and running a regression again. These are coefficients. And use this package car to do multicollinearity check in R. And again, you see for each variable, value is less than 3. It means, again, no multicollinearity.